says that we're streaming, it says we're recording, but I cannot see. Whew. Can I not do multiple streams each day? Is that not how YouTube does it? I'm live, there we go, okay, nice. Can I not do multiple streams each day? Is that not how YouTube does it? Nice, okay, we're here. Alright, so we're back. You know, we in it. We in it. Alright, so, we're gonna be, so this is just gonna be a little bit different than what I was doing before, was just like saying whatever I think and eat and preparing food. But we're gonna have dinner here, and we finished our meal prep for the week, so that's good. It's done. I want to do a little bit of studying here. Yes. Not really studying, but just problem solving. So this is kind of an interesting question. I have an idea for the solution. I'll go over that shortly. I should eat as well. So this is this not? Okay. Anyway, right. So as far as the solution for this problem, I want to do two checks. We'll just do a point-by-point check. So it's if two rectangles overlap with each other. We'll check if every point in one rectangle, if or if not, it's present in the other rectangle, and vice versa. Obviously, if that point is in the other rectangle, then there's an overlap. If it's not, if they all those checks fail, then you can do another check, which is to see if there's like a cross kind of thing going on, which you need only check that the upper bounds of one rectangle is inside the upper bounds of the other rectangle, and the other rectangle, the outer bounds are contain the I guess left to right bounds of the one that's sort of supposed to be like the cross, the upper skinnier part of the cross, or rather the vertical part of the cross. Yeah, I'll test that. And those two checks should be sufficient. Let's see if there's another question. Maybe we should just code it and then look at the next question and take a few bites. So we'll do this till about 9 o'clock, and then we're going to sleep. Yeah, 9 o'clock, then we're going to go to sleep. Oh, itchy. What is it saying? So, yeah, we'll perform those checks. We'll program that. We'll take a bite and then start programming that, and then we'll see if we get it correct or not. If it's correct, then we'll move on. If not, then we'll stay on this problem. Yes. Yes. trying to fit this on one line because it looks kind of ugly if you don't fit it on one line. And readability kind of matters. So I'm not really sure. Like these are, I guess, permutations of x1, x2, and y1, y2. It's actually like itertools product, right? That's what I want. I think that's what I'm looking for. Oh, HackerRank. Okay, nice. They hacked Google, and now it shows up. First thing you search. Neat. I'm kind of curious what this will print. Right. Zero 0022. Oh, I did it wrong. That's why. One 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 three three one three three. Oh, that's actually correct. That's what I want. That's actually exactly what I want. So yeah, we're just trying to avoid redundant code here as much as we can. Keep it terse and simple. So now we want to have, there's another check. That's like an intersection check. And I guess it looks something like this. I had a hard time describing this. So even in my mind, I'm thinking I'm going to have a hard time programming it too. So the idea was, you can go and check in both directions, I guess, but you say, take the top. What you want to check is that the top and bottom of A includes the top and bottom of B. So top and bottom of A are, they include top and bottom of B. And then the left and right of B includes the left and right of A. And then you do or the inverse of that. So we'll say top and bottom of R1, which is top bottom of R1 excuse me. Do it this way. X1, Y1, X2, Y2 of R1, top bottom of A, or let's say, let's do it exactly as I just described it. Top and bottom of A is, let's say, hold on. Let's do it this way. Okay, top and bottom of A is A of 1 and A of 0, 1, 2, 3, right? Top A. And you know what? You should do it even better than that. We can do, there's top is Y1, bottom is Y2. Now, do we always know X1, Y1, the coordinates of the bottom left corner, and X2, Y2 are the top right corner? Okay. So actually the top is Y2. and the bottom is y1, and the left is of A is x1. Excuse me. And the right of A, alright, same thing. Okay. Oh, if they only touch at the corner, they don't overlap. Well, this makes this a little more interesting. If this is on the edge, actually, it makes it a lot harder because they have to make sure that in those cases where they're, is there a possible case where it's not clearly in? Yeah, there are cases. So you could be like this, right? At one of these corners. Clearly, if you've got anything like this going on, excuse me, but you might have something like, I'm actually thinking something like this, right? What if it looks like that? Yeah, that case could occur, and you're not going to pick up, even though the corner is in, it is contained. It's going to think that it's like here or something. Yeah, that's kind of awkward. Oh, this is This guy Lee asks some difficult questions, in my opinion. Good ones, but tricky ones, challenging questions. This is kind of harder than I would expect, in my opinion. Yeah, there's a few different cases like this. I don't know, man. I don't know. Also, it's not clear if there's any degenerate cases with the rectangles. Could make that its own function as well. That's fine. What else is there to consider? I'm thinking something like this. Maybe. Yeah. Okay. So there's a few sort of cases that this breaks down into. We can handle this, but it's just you got to pay attention to it. So this is like A and B is a point, right? So this is A, B is this point. This point is it's equal to x1, but it's also less than x2, right? And it's equal to y1, and B is equal to y1, and it's less than y2. So it's exactly on the edge. There's not enough information to tell, excuse me, if this overlaps. Yeah. With just that point. Oh, it's so annoying. Shoot. I thought I was able to nail it down to 2 cases, but the fact that they want non-zero overlapping makes it more interesting. Actually, in this case, there's not really an issue, right? Because this point will get caught. That's really not a big deal. I think any case like that actually will get caught. So I take it back. Not actually as much of an issue as I'm making it out to be. We'll go back to what we had originally. Take it back. We can just do it this way. Okay, so intersection, we say the what about this case? So we can do less than or equal to. That's fine. I don't know if I could write this way, but I hope I can. That would be useful. This probably looks a little confusing, but the left of B is going to be less than or equal to left of A, which is less than or equal to right of A, which is then less than or equal to right of B. And then we return right 1 and right 2. Now we want to say intersection check is intersection of rec 1, rec 2, and intersection of rec 2 and rec 1. Yeah, and then you just return point check or intersection check. And that should do it. That ought to do it. I kind of want to just YOLO it. I can put a bunch of test cases in there though, I guess. Although, it's always got to be bottom left, top right, right? Can always finagle your point such that they're set correctly. I kind of just want to submit it. I don't want to go through a bunch of test cases. Well, maybe we should. Let's just see how it goes. Oof. What happened? think this should be or, not just and. If you're, yeah. Hmm. Alright. YOLO. Oof. Oof. Alright, let's see what we get wrong. This is an interesting question. I kind of wasn't expecting to get it right, because I was thinking, like, you know, there's probably some test case somewhere that I missed. So we got it wrong, huh? 7, 8, 13, 15. Dang, man. Dang. Shoot. Shoot. 7, 8, 13, 15. Okay, so 7, 8, 13, 15. Fine. And what's this? 10, 8, 12, 20. So 10 is maybe here, and 8 is right here. So 10, 8. And 12, 20. 12 is like here. And then 20 is way up here. 15, 20. 12, 20. It's like approximately here. Right, relatively speaking. Okay. Alright. So it should be true. And we returned false. Really? Why though? This should have been true. Wait, what? We exactly handled this case, or I thought I did. Or at least my logic wasn't wrong, but my programming of it was incorrect. Oh, did I say and or with the intersection? Ooh. That's supposed to be an or. That was my mistake. Yeah. Hey. Nice. Not too shabby. Alright, so that's rectangle overlap. That took a while. That took a while. They have a thing too, which is good. I'm gonna remember that problem. Going to remember that problem. It was an easy one, but one of the harder easy ones, in my opinion. What? What do they want? So it looks like you're going to sort, and you're going to assign an index. There's a sorted index, so we're going to sort the numbers. we could enumerate first and create a sorted list of the number and its index, and then we can sort those tuples on the value in descending order, and then we can say we can then map the first 3 to a string rather than an integer, and which is gold medal, silver medal, bronze medal, and then we can actually walk through, I guess, maybe an array of indices, or even, yeah, I don't know, actually, I don't know. We're doing something with a hash map and sorting here. This is very easy, but you need to be a little careful not to do this incorrectly. So you want to do something like this. Okay, let's do it like that. I'll show you. It's easier to show it than explain it. So we have value index in enumerate nums. Right. And we want to do is ret.append, or actually no. Yeah. I think enumerate is a what do they call that? A generator. So we'll put this into into an array. And we want to say lambda is for x. It's going to be sorted on x of 0. So if so if this array, it's sorted on the value, and it's going to be, an increasing. No, I want to do decreasing. Sort decreasing. Descending Python. Reverse is true. Apply computer vision. Right. And then what we want to say is ret x in array, ret.append. We'll say val is going to be range length of array. be value is going to be the array of x. Call it I. No. It's just going to be I. Say val is going to be I. So if I equals 0, I equals 0, or even easier is this way. Gold medal. We'll do it this way. Just a straight mapping. That's it. Yeah, something like this. I tend to forget the key. Four, 5 is strings expected. Oh, these are supposed to be strings. Okay. All right. Okay. That's fine. Oh, of course. If it's already a string, it just returns itself, right? Hopefully. Okay. And guaranteed to be unique. Scores. Given scores of n athletes. Is there empty test case? Input, output expected. Okay. And how about if we have like 1, 5, 4, 2? Output expected. Aha! Not quite what we're after. Okay, that's interesting. So there's supposed to be a mapping going on here, I think. So we sort it. We sort the enumeration based on the value, and then, oh, that is a mistake. Actually, we want nums of I. So nums of I. Oh man, that's confusing. It's actually, shucks. We want to assign to, oh man, my head. Shucks. It's like mapping's going on here. It's just kind of confusing. So what we want to do is sort. So now we have the order of the indices in the order of. Oh, I see. Okay. So it's actually going to be something like this, like ret of times the length of nums. And we want to set ret of I, no. We move for x in this sorted array, right? No. Yeah, okay. Set x equal to this sorted array of I. It's really going to be an AB for each of these tuples, right? So you've got A, B, and I. Now, ret of I No. Ret of B, there we go, is going to be, so val is going to be I plus 1. Ret of B val is going to be equal to I plus 1. Ret of B is going to be this thing, string val. There we go. A little confusing, but that appears to be what we're after here. Assignment index at a range. Really? No? What? 2, 4, 4, 4. Length of ret B is a value and index. Nums. Length of ret is the number of nums. What is this? What the heck is this? What? 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 4. 1, 2, 4, 5. 2, 4, 5, 1. Huh? What the heck? Or is it IV? Am I doing it wrong? It's index value. Oops. Oops. Shucks. Huh. Bronze metal, silver metal, gold metal. Output expected gold, silver, bronze. How did I get that wrong? What? Wait, what? What? What is going on? Ah, I don't know what's going on. The mapping is backwards. The mapping is backwards. So if we say reverse true, the largest values are going to come first, right? So the index here, ret of A, the largest index, right? That's the first one, should be. So how did, what? One more time? Why is this taking me so much time? What the heck happens? So 1542 certainly 1, 2, yeah, so 4 is 1. Okay, that's correct. But 2, when you sort this something 2 should end up in the front. When you, oh, that's why, because we're not, okay. I'm not sorting it correctly anymore. Right, because of the, there we go. Okay. And let's go with empty. Alright, good. And 1, whatever. And we can put whatever value we want in here. Neat. Neat. Interesting question. Interesting question. We're also going to YOLO it. Nice. Got him. Okay. Interesting question. Got a lot of downvotes. Are these the only 2 questions I worked on today? Yes. Nice. Nice. What does the discussion say? Easy solution sorting. ON without sorting? Oh. That's impressive. How do you do this without sorting? Oh. Okay. Oh, I see. He used, yeah, you don't need to sort it, I guess. Oh, wait. What did he do? What the heck did he do? Result. Max is 0. For each integer, if I is greater than max, max equal to I. So the largest value is the maximum. Oh, he did, yeah, he did a counting sort. That's not, he did sort it. Liar. It's counting sort. I was gonna say, it's like, how did he do this? This is a counting sort. This is not. Okay. I was gonna say you could do counting sort, but two-liner. Whoa. Whoa. Oh, I've not used this in a while. Excuse me. Excuse me. Oh, he just combined what I did. Okay. Sorted nums, reverse true, enumerate for IN, and then he just did this or this or this. I'm not really sure. I've not seen this before, though, personally. So rank is. Yeah, it's the first time seeing this notation. Super cool. Yeah, that's pretty neat. I like that. String of I plus 1, or this thing for IN. What does this do? Oh, I see. You do an AND. Oh, really? That's interesting. So this is true, and I greater than 2. What does that do? What is that Python bracket notation? What does that do? No idea what this does. 2 hash table types. Oh! Oh! It's a hash table. Oh! I didn't even think of that. So it's a list comprehension in a hash table. A dictionary, rather. Oh! Wow. Wow. Very interesting. So it's going to be n mapped to this thing for in this enumerated sorted in the reverse direction. Very cool. That's neat. I like that. I like that a lot. Very nice. Okay. All right. We're going very slowly here, but that's fine. That's fine. That's okay. It's not a race. I think we've done this one already. Solved this one. So first things first, we want to write a short routine that just deletes a node from the linked list. In a singly linked list, this is straightforward. The thing that's tricky, though, is oh, it's already sorted too. Okay, so this is even easier. I was going to say we can use the Hashmap, but no. All we need to do is loop over the list, and just don't delete the first element. Interesting question. Interesting question. Okay. So remove node. Let's say we have target. We have a prior node. So we have the previous node, we've got the target node, and all you've got to do is say previous.next equals target.next. And that's it. It's removed. It's removed. Yeah. We'll say t equals head, while t. We say current value. So we should describe it in English first. So we'll have some current value, and we'll say if the value is equal to the current value, so the value of t, after you go t.next, you say, first thing is current is going to be negative infinity, right? Well, actually, can have whatever value you want, right? Assuming these values are not so let's do this. Let's say current is t.value and t equals t.next, right? And we'll say while t, then we say if t.value is equal to current, and then we want to remove this node, which is so if previous and t, current equals t.value. Previous is going to be t, and t is t.next. Say while t exists, we're going to remove node with previous, and the target is t. Else, we are going to set current equal to t.value, and then we set t equal to t.next, and that should do it. And we want to return head. Okay, how do we do? Okay. 1, 1, 2, 3, 3. Let's see. Output 1. Oof. Oof. Really? What? 1, 2, 3, 3, 3. little confused by this. Did it get cleaned up, maybe? Is that why? Seems kind of surprising. I'm a little confused by that. What? What is going on? None. Really? What the heck is happening? 2. Okay, so this 1 should be pointing to 2. I don't know why we end up printing just a 1. Is it not? The heck happened? What's going on? What? What? Oh, that's why. Oh, of course. Oh, I see the problem. Duh. It's like, that's funny. Not even paying attention here. It's like really obvious thing. It's sorted, right? So, alright, I don't know. Could we just throw more stuff in there? What? 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 Why does this not have an issue? What is going on? 1, 2, 3, 4, 5, 6, and it only removes a few of these 7s and a few of these 8s. It leaves a bunch. So this 7, what the heck? Oh, is that because it points to T rather than? Oh, I think I know why. That's confusing. Yeah. So, so you remove T, but this previous ends up pointing to T. Right. Right. So T equals T dot next. But what previous is equal to is so if they're different, then previous ends up being equal to whatever T was. If you got to remove T, then you don't change previous. I think that's the key here. There we go. YOLO! Oh, of course. Man, I get so tripped up on these easies. Like it just trips me up. It just trips me up. And just do a sanity test. Check. Sanity check. And what do you return? Return none? Or just return head? Alright. Alright, what do we get wrong? What do we get wrong? Okay, we're right. Fine. Jeez, dude. Jeez. Like, oh. Wrong. Wrong answer. Bunch of questions asked. A bunch of companies asked this one. Oh. Oh. It's like, fuck. That's from a while ago, 86. Okay. 7:30 p.m. now. Kind of want to just lay down for a few minutes. I just want to go lay down for a few minutes. I recognize that it's like, it's your duty to do as many of these as we can, but I want to say I'm kind of burned out, but couldn't even get through all the easy ones before feeling like, oh man. It's funny too, like these are supposed to be easy ones. How are you going to get through 500 mediums? You can't even get through 300 easies and then 200 hards. I don't know, man. Like, ready to go to sleep, ready to go lay down. Alright, I'm going to lay down for like 10 minutes. That's very funny. Just read this first. Give an array of numbers and a value val. Remove all instances of that value in place. Return the new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with O of 1 extra memory. Order elements can be changed. Doesn't matter what you leave beyond the new length. So I think what you're supposed to do is like swap the value out with something. Doesn't matter what you leave beyond the return length. Excuse me. So you're going to do it in linear time, unfortunately. Yeah. Kind of lame. Why is it? What is this? A lot of downvotes. So I'm confused why the return value is an integer. Answer is an array. Input array is passed in by reference. Means modification of the input array will be known to the caller as well. Internally, think of this. That's very funny. All right, we'll go lay down. We're not doing any thinking, just laying down. Just laying down. Oh boy. I should leave the phone here. Put some of this stuff away before we lay down. Time moves by very quickly, though. Holy smokes. Oh, how I've noticed. So we still have tomorrow, right? We got tomorrow, make a little MGTOW video, or make our MGTOW video. There's something I did want to say to fathers, guys who are currently fathers, who made the mistake of having children before they were ready, or alternatively, making the mistake of having children in the post-apocalyptic world we're currently living in. Yeah, for those guys, I do have something to say that may be useful for them, maybe helpful. I was thinking about putting a boatload of other stuff in there, but the other things are maybe not really worth pointing out or talking about. Actually, I'm gonna use the bathroom. Let me reset the clock here. I want to give myself a genuine amount of time to lay down. I think at least 15 minutes. Let me also put this down too, or at least just mute it. Give me just a moment. All right, I'm gonna lay down. Just lay down. That's it. That's it. Oh, I'll get at least another hour in of some of these problems. All right, okay. Not too challenging, but man. Oh. Ay, Dios mío. Ay, Dios mío. Anyway. Oh. Yeah, we'll just keep going through these problems slowly but surely. Slowly but surely. Oh man, there's a boatload of things for me to think about, but I think the simplest thing to do is apply to something that could be remote positions, apply to a bunch of companies. See if I can get in to those companies, said companies. If I can, that'd be great. If I can't, sad days. We'll just stay where we're at then for a while. Yeah, the goal is to get a remote position sooner than later. That's the first thing to do. Could talk to my current employer about that. Could talk to other companies about that. We'll see. Optimally, would want to get something remote with my current company because I know the software and I know what they're up to, what they're doing. I don't want to say I know the business, but I think I have a pretty good grasp of how it all works. Yeah, it would be better not to just like drop everything you learned for another company. So yeah, so there's that, and then and similarly, you know, if they probably don't want to have to hire and train someone brand new to replace me if they can avoid it. So it's good for both of us. So they would be more inclined, I think, to go for that. Although I probably want to talk to my managers on a good day about that. hopefully on a day that things are going well, something like that. About moving towards the remote work. I think that's the first goal. There's a boatload of other stuff that I've got on my mind, things to do, things to approach, but it's like, oh, I gotta do one step at a time, you know? Just focus on one thing at a time. One thing at a time. One thing at a time. I'm not even sure if I should bother. I mentioned that, right? I was thinking, well, I should maybe go on, what is it, Christian Mingle and eHarmony and what have you, and look for a partner. But the truth is, if I'm trying to pop out 12 kids with her over a 9-year period, I probably want to hold off for a bit as far as like my own looking for someone. Yeah. Yeah, I probably should wait longer, actually. Not really bothered thinking about women at all. Yeah, because it's like, well, she'll be, if you marry an 18-year-old, she'll be 27 by the time you're done with all that. And not to mention you'll have 12 kids to take care of after that. Which I don't really have the time or resource to take care of 12 kids right now. And I'm not going to have that for probably a few years. At least not like 5 years, probably. So I'll just hold off for, I guess, 5 years. I suppose I'll need to keep in shape, get myself in shape. Yeah, build things out in the next 5 years, get things prepared, get things ready. Get myself ready. Yeah, I'll be 27 at the end of this year, so I'll be like 32 at the end of. Yeah, I think around 32 should be the good number, the right mark to really start looking for a partner. And then hopefully I can find someone within about 3 years. Yeah, I'll hopefully be where I want to live the rest of my life. I'll hopefully have the land picked out and have the job and the money and the career and all that. Maybe not career, but just at least have enough cash to settle myself and build, start building a real big complex kind of thing. Build a little cabin first. The first thing is just get into a remote position, get my butt out to out in middle America, kind of a place. The Ozarks is where I got my eye. But yeah, like Nashville, an apartment somewhere in Nashville, I think is not bad. And my brother wants to move into Tennessee too. He and his wife, I think they're thinking about doing that. So I'm thinking I'll move to Nashville as well, so I can be near my brother. And I don't know what my younger brother is thinking, but my mom said she'd be interested in moving out to Nashville too. So my mom might be coming along, and then my sister would probably go with my mom. I don't know what has a job, but I don't really know what the deal is with that. Exactly, if she could move or not, or if she wants to. My younger brother, he's got business investments here in New York. He's making a boatload. I think I've mentioned it a few times. He's paying $8,500 a month in one of his stores, and his other store he's probably paying a few thousand. So he's probably making a good number above that. Probably making at least 50 grand gross a month, probably even more. And he's doing well. I bet he's doing well for himself. Yeah, he hustles. Finds things that make money, and he just focuses on that super intently, which is great, which is good. Doesn't bother with this public education brainwashing high school nor college. Neither of them he didn't bother with, which I used to think was actually a negative thing, because it's like, well, look, you're supposed to like do your duty and be a part of society and all that. It's like, no, society is completely corrupt. It's actually of great benefit that he didn't do that. Oh, that's tragic. That's a nightmare. That's horrible. Yep. Welcome to 2019. Hallelujah. Hallelujah. Just Just kidding. No, it's hallelujah. That's not using the Lord's name in vain, right? That's fine. That's not blasphemy. That's I can say that. I think. I hope. If we could just in case, just in case, repent just in case. If that happens to be something holy that I'm not supposed to take in vain, I repent. I repent. We'll do it again. So don't take holy. I guess that's true. If you don't know if it's holy and you're taking it in vain anyway, probably is just as bad, right? Shouldn't even pretend. Shouldn't even go close. Go near it. Welcome to 2019. Corruption abound. Corruption and broken dreams abound. Yeah. So I think, That's not a bad plan. Not a bad plan. Not a bad idea. Yeah, man, I got a bunch of things I want to do that are tech related, things that are more like side project kind of things, but I should definitely focus on just one step at a time. Yeah, I should definitely focus on getting myself situated, just to figuring out where I want to plant myself. I think that takes priority over these side projects, even if they would make a boatload of money. I mean, we're talking like billions. It's like there's a bunch of things you can do that are worth a lot of money. Numerous things now. Numerous. That's okay. Don't need a billion in your life. You just need enough. And yeah, if I could work somewhere remotely, and then make developer salary at that job, and go to and live middle America, more rural America. You don't need billions for that. You can raise 12 kids on a developer salary, absolutely. If you own your home, you build it yourself, and own, that's it, you own the property. Easily. Because all the money you're making is pretty much going to right to the bank, or right to the taking care of your family. So that's a good life. That's a good one. That's a good one. So this is just, we'll have a pointer. The thing about this is it's the order of elements can be changed? This is ridiculous. This is ridiculous. I should say it's ridiculous, but there's an algorithm I'm thinking of. I'm wondering if it can be used here. It's like a three-way partition. I forget what it's called. No, not this one. No. It's like Irish partition or something like that. No, not that one. Not that Irish partition. Not Irish. It's a smaller, equal, greater partition. Array partition. There's a name for it. I don't know what it's called in this algorithm. It's a quicksort partition. Not quicksort. Whore partition. No, it's not whore partition. It's the other one. It's not whore partition. It's similar to a whore partition, but it's not. Low, high partition. Lamudo? Unbelievable. Cannot find it. There's a way. Integer array. Oh, it's got a name. What's it called? Can't remember. I do not recall. It's got some funky name. Single pass integer partition. Ay, Dios mío. Partition algorithms, array partition algorithms. There's a specific algorithm I'm looking for. No, it's not the quicksort one. No. Oh, no. No. There's a special type of partitioning algorithm. Hold on, let me see if I can find it. The wiki. Computer science. I'm gonna go nuts, man. I don't remember what the name of this thing is. It's not a sort. It's like single pass partition of a integer array. Dutch national flag. There we go. Three-way partitioning. It was three-way partitioning. Dutch. Never gonna forget that now. The Dutch. Yeah, there we go. The Dutch flag problem. Yeah, this one. Okay. Why was I looking for this? Okay. Rearranging elements of an array. One of three categories: bottom, middle, and top. All the elements are in 0 to 1. The bottom can be defined as the 0 to 0.1. The middle is 0.1 to 0.3, and 0.3 or greater. Bottom or less than. Okay. Right. So, okay, this algorithm is an interesting one. The Dutch national flag problem, it's called. Basically, you want to sort. You want to. Three-way partition. Excuse me. Yeah, so you maintain a middle group. So you've got a bottom group, an upper group, and a middle group. And you're gonna partition the array as such. So my thinking is I'm wondering if this DNF partition is useful at all. I don't think so, actually. But it seems like the kind of thing that we're looking to do. I think realistically, you can just swap with a pointer that starts at the end. Each element you see, if it doesn't matter what the order is, then yeah, you can swap with the returning the new length, it says. Okay. So the pointer to the end is going to come closer to the front from right to left, so move from right to left. And yeah, you just swap. When you find what you're looking to remove, you just swap it with whatever's at that pointer, and then increment the pointer, and then stop when you've hit that pointer, and return whatever that index is. That's it. Real simple. Can do it this way. Hold on a second. Oh yeah. Terminate early. 3-2. Oh, that's interesting. Huh. Oh, okay. All right. All right, it's not great, but it's okay. Oh, interesting. Output 2, so it goes 0, 1, 2, 3. Back is 3. Right, goes back 2. If I is equal to 2, return I. 0 is 3, which is what we want. So then we swap 2 and 3 and decrement the back to 1. So now I is 1, back is 1. And we end up returning 1. Oh, yeah. And then I guess we pass through the whole thing. I mean, we're always going to hit here. This will never be reached. But in theory, whatever the back is, some index. Technically, back plus 1 is what we want, I suppose. What if we have empty set, input, output, expected, negative values. Can we have negative numbers? I don't want to submit it yet. Output, expected. Oof. What? Oh. Really? Oh, that's interesting. Wow. Okay. So back starts off at 4. We get to 3. This fires. We swap 3 and 4. So there's negative 10 here, negative 1 here. Right? Back becomes 3. Oh, I see. Zero, 1, 0, 1, 2. Back is just 2? Shouldn't? What? 0, 1, 2, 3, 4. Back is initially 4. Negative 10 is not equal to negative 1. So back is 4. Increment I a few times. 0, 1, 2. I is 2, they're not equal. 3, when I is 3, back is 4. We swap back and nums, right? And decrement the back. So now it's back is at negative 10. And I is 3. Right, so if this is greater than or equal to 2 back, you really want to return the back. guess back +1. Maybe I should try a few more test cases here. I don't want to just YOLO this one. Seems like my tests are failing pretty badly. So -1 and -10, that's fine. But this -1 should go into the correct spot as well. Oh, because it's a -1 there. That's why. It skips all the -1s. Yeah. That makes sense. That makes sense. And then what if we do something like this? Oh, this is tricky, man. This is a tricky problem. That's correct. Oof. Yeah. That could just be 0. Or rather, back can go all the way to -1. YOLO! Hey, got him. Got him. This is it's a bit precarious, you know. That's okay. Move linked list elements. Okay. Yeah. Okay. Move all elements from a linked list of integers that have value. Val. Excuse me. Okay. Should go get the one that we removed from the sorted list, right? Yeah. This one should copy this code. Copy pasta. Man, I wish I could play copyrighted music. There's a bunch of music I want to listen to right now. Some good programming music. Some good stuff. So what we want to do here is, instead of this, there's no current anymore. It's just current equals val. And that's it. It's effectively the same code, except just, you know. Alright, it's empty. What happens? It's a bunch of 6s. What happens? Ooh. Oof. Okay. I actually don't want this part. You don't change this either. So the other problem, you always had the previous, it was never null. if not previous. Then t.next is t.next next. Yeah, the head's not necessarily preserved here. If there's no previous, then you're going to set head equal to t.next. And actually it'll be, and right, t equals head. That's an interesting question. What do you do here? If the previous is null, that means you're looking at the head, and you want to bump the head up to the next value in the linked list, and you want to set t. You're going to get t.next anyway. Let's see, how's that look? Okay. And what about something like this? Okay. And what about something like this? Excuse me. A few different cases to test. Alright, that should be good. YOLO! Nice, got it. Something I forgot about is that you want to test, like there's certain test cases you want to look at. And that should usually be sufficient for your testing purposes to be confident that it's correct. Valid parenthesis string is either empty, a plus b, where a and b are valid parenthesis strings, and plus represents concatenation. For example, valid parenthesis string is either empty, something a, or a plus b. A and b are valid parenthesis strings, and plus represents string concatenation. For example, here's this, and this are all valid parenthesis strings. Valid parentheses string is primitive if it is non-empty, and there does not exist a way to split it into s equals a plus b with a and b non-empty valid parenthesis strings. It's primitive if it's non-empty, and there doesn't exist a way to split it into a concatenated b, where they're both non-empty parenthesis strings. Given a valid parenthesis string s, consider its primitive decomposition s, p1 plus p2, etc. P sub I are primitive valid parenthesis strings. Turn s after removing the outermost parentheses of every primitive string in the primitive decomposition of s. What? Oh, okay, so this is primitive and this is primitive. And so you end up with this output. This decomposition. Removing outer parentheses of each part. Oh wow. That's a neat problem. So this one is easy. So I think to identify basically you can use a stack. You don't even really need a stack. Well, I guess you could. probably what you want is yeah, this is relatively straightforward. We'll use the stack. So the idea is the first outer parentheses you push onto the stack. Like every time you see an outer parentheses, you push onto the stack. Every time you see an inner parentheses, you pop from the stack. And when you've popped, so if the stack has at least one outer parentheses on it, so it's greater than or equal to 1, the size of the stack, you're gonna append the thing you're looking at to the after potentially popping the stack. It depends actually. If it's an open or closed, then you need to check if it's open or closed. If it's a closing parentheses, you're not necessarily going to print it. Yeah, you pop the stack after you check whether or not you should print. So that's it. It's really straightforward. So I'll show you what this would look like. There may be a better way to do this, but we'll do it this way for now. Say if x is equal to open parentheses, then we say if actually it's probably better to do that. If length of stack is greater than 1, then ret plus equals this character. And we push stack.append. Right. Else if this is equal to the other one, length of the stack is greater than 1. Now, this is greater than or equal to 1. This is greater than 1. Slight difference here. Subtle difference, but important difference. And we pop the stack. Okay. So it's always a valid parenthesis string. That's kind of important. So let's do each of these test cases. Not entirely sure. So we're not going to do any error checking on the input to make sure it's valid or not. Yeah, I'm not going to do that. All right, YOLO. Nice, got him. Got him. Deeper, I'm falling into the arms of sorrow. Okay. Reorder log files. Have an array of logs. Each log is a spaced delimited string of words. Each log, the first word in each log, is an alphanumeric identifier. Then either each word after the identifier will consist only of lowercase letters, or each word after the identifier will consist of only of digits. We'll call these two varieties of logs letter logs and digit logs. It's guaranteed that each log has at least one word after its identifier. Okay. Alphanumeric identifier, the first word. Each word after the identifier will consist only of lowercase letters or only of digits. Okay, so there's some alphanumeric identifier, and then we've got only lowercase letters or only digits following that identifier. Neat. Okay, so reorder log files. We will call these two varieties letter logs and digit logs, guaranteed that each log has at least one word after its identifier. Reorder the logs so that all of the letter logs come before any digit log. The letter logs are ordered lexicographically, ignoring identifier, with the identifier used in case of ties. The digit logs should be put in their original order. Oh wow. Neat. Turn the final order of the logs. That's an interesting question. Yeah, it's something you probably want to do in Python. This is the kind of thing you might end up doing, like if you're, quote unquote, working in fintech. These are the kinds of scripts I end up writing quite a bit of, things of this nature, where you've got like one example of a script I wrote recently was a very small script, but it's like, okay, you've got a bunch of process sessions that are up or down, and you've got a log. There's one line in the log that lets you know which sessions are up and down. So you've got to find that line in the log, parse it appropriately, and then print on a certain set of lines the sessions that are up, and then at the end of it all the sessions that are down. Very simple script in Unix, like Unix one-liner, but that was something I did recently. And there's a bunch of little scripts like that. You get little things here and there. Yeah, this is like pretty close to something you might actually do within a couple of minutes on the job. Call these two varieties of logs letter logs and digit logs. So what do they want? They want the logs so that all of the letter logs come before any digit log. So you want to, and the letter logs of a certain order. So you want to really break this into letter logs and digit logs. And the digit logs have whatever order they had initially. So we'll create two arrays. One array is the digit logs, another array is the letter logs. And then we'll sort the letter logs as appropriate, but the digit logs will leave in the order that they're sorted in. And yeah, you print the letter logs and then print the digit logs. Yeah. Interesting. Okay, so let's do that first. Let's get split into letter logs and digit logs. So, each log has at least one word. So we can just look at the second word. So we can say for x in logs, if, let's say, a, b, or just, so abc is equal to x dot split, right? And we say if b of 0 is digit, do you have an is digit routine in Python? Is digit. We could write one, but I might rather use the dot is digit, and then dot is alpha. So these are guaranteed though. So if b of 0 is a digit, that means you're looking at a digit log. So we'll say digit log. Excuse me. And then there's, what's the other one? Letter log. Letter log, digit log. Is digit, we say digit log dot append x, and letter log dot append x. And that's it, at least for that part. And now I want to sort the order letter logs, right? So lexicographically ignoring the identifier. So we want to say sort our letter log dot sort, and we'll have key is lambda x. It's going to be how do you get the lexicographical value of specify comparison operation. Key equals comparator. Passing as a comparator function. Turns it into an appropriate comparator, proper comparator. Make comparator less than compare xy. If less than xy, return -1, else if return compare. Oh, that's interesting. Should be using key functions. This is a little bit confusing. I'm still kind of getting used to it, what this does. But this is going to create what you're looking for, this comparator. So make comparator, and we'll say, yeah, function compare xy. So it'll return a function xy. So it returns a function that takes x and y using the function you give it. So you're going to use a key make comparator of, and the function is letter comparison. And we'll say oh, I see. Okay. You actually could just use letter comparator, letter comp, I think. Like, I don't think you actually need all this. It's not key, it's comp equals letter comp. And we'll say actually, maybe we should do it the other way around. Take it back. we should do this. We'll say X and Y. So these are it's not a key, it's a comp. So we want to do, what do they say? So it's letter logs are ordered lexicographically, ignoring identifier. Okay, so we'll say tx ty is going to be x dot split of ignoring the identifier and join dot join, and similarly right, and we're going to return tx less than ty. I would say if tx equals ty, return identifier used in the case of ties. Okay. I did that wrong anyway. Did that wrong anyway. This is B and this is A. A of 0 is less than B of 0. So use the identifiers and txty. Alright, so if they're equal, you return, use the identifiers. If they're not equal, then use lexicographically smaller of the two. So then this will turn this letter comparator into a proper compare function, and then return that, and that'll be our compare function. Neat. Neat. And then ret is going to be letter log plus the other one, which is digit log. And I want to just print this. Well, actually, we're just return it. The test case will show us. Whew. Invalid syntax, line 6. Thank you. Comp is an invalid keyword argument for this function. Really? Where's that Stack Overflow? Oh, maybe I need sorted comparator. Okay. Do we not have sort comp? Yeah, it doesn't have a comparator. This method only, okay. So there's a considerable difference between these two. Cannot give a custom comparator to this guy. Doesn't sort in place this one. Okay. Okay. Invalid. Oh my goodness, please. Please. What do you mean? CMP equals. What? Invalid keyword argument. What are you talking about? What? What? What do you mean? What do you mean? What? Oh, it's loud. Iterable key reverse. Oh, what? Where's comparator? Oh. Old style comp function to a key function. Comp to key. Oh, that's interesting. Oh. I guess I gotta use the key. Oh. You know, I was so confused by this originally. It's actually really simple what this does. But when I first was looking at it and I was trying to use it in the past, I was just utterly flummoxed by what this thing. Wait, what does that work? Hold on. No, I still don't get it. I still don't get it. How does this make what? Old style comparison function to a key function used with tools that accept key functions. This function is primarily used as a transition tool. I'm still flummoxed. I don't know what this does. It does something else entirely. I don't know what it does exactly. From func tools, import comp to func. Comp to key. So we actually need to take key equals comp to key of make comparator. What? Wait. Okay, I don't know what this does. This comp to key. It actually it takes so we've got this letter comparator, which then converts it to a proper comparator, right? And then that proper comparator is then converted to a key function. So what does that mean? What is that? I don't understand. Like how does that do that? I guess it's gonna give whatever. I guess you're gonna have like a sort of topological kind of sort going on. This comp to key is gonna take your comparator function. Excuse me. And then you can use that comparator function in place of the key function, which the key function would normally generate a value, and then you would sort based on those values. What this is going to do is it's going to, I guess it'll generate values internally or something. I don't know what this. How is this implemented? Like, what does this do? What does this do? What does the comp to key? Python docs, Python's open source, right? How is the implemented? This is also an interesting interview question to ask somebody. Not that you'd expect them to know the answer, but that's just a hell of a question to ask. It's an interesting, if they knew the answer, that'd be amazing. That'd be amazing. So how does this work? So how is comp to key implemented? Source code. Okay, that's all. Comp to key function converter. Oh boy. Try from func tools, import comp to key. Accept import error, pass. Okay. So you return this key object, which is a key of k of. Wait, what? So you got your comparator function. So the key. Oh, that's really simple. Oh, okay, I didn't get it. Didn't understand. So it just returns a true or a false. Oh yeah, because the other comparator just gives you 1, -1, or 0. So what this does is this returns true or false. It's actually really simple, I guess. Slots hash class k object return k. Right. So k is a class, and you can compare this object to other objects. So it's a key that you can compare the key to. Oh, that is so interesting how this is implemented. Wow. Talk about an abstraction. That's really neat. That's really cool. Wow. It's like super simple abstraction, but what it does is, in a few sentences, so your key doesn't actually need to be a real object of any kind, right? All it needs to do is be an abstraction of an object that when you compare key A to key B, you have less than, greater than, equal. You can do comparator operations. So less than or equal to, greater than or equal to, or equal to. You just need to have true false values for two different keys when you're comparing them. So you don't actually need the key to be any particular object. It can just be an object that literally has those functions defined. And then when you compare two keys, like defined for each key has that interface defined. And then to define that interface, you can use the comparator function. Oh, that is amazing. So all you need is the comparator function. You don't need the keys don't need to have any absolute value, I guess. In other words, like when you compare integer objects, it's clear whether an integer a is less than or equal to when you can compare integers a and b. This is suggesting you don't actually even need to know what the value of the integer is. You just need to know that you can compare these two key objects. Oh, that's very interesting. Wow, amazing. So you could even write this yourself if you wanted to. Yeah, you could ask someone. That's an interesting interview question. That's a heck of an interview question. If I was going to interview somebody, I would ask them some crazy questions. They'd just be like, "What are you asking me? Why are you asking me these things? I don't know. I don't understand. I don't know, man." It's neat that Python is totally open source. Wow, that's cool. Okay. Neat. So that's how you can, okay. Neat. All right, and what's the answer? Are we correct here? just gonna YOLO it. These examples are too long for me to write. Wrong answer. Nice. Nice. Okay. Output. Expected. I'm a little confused. Wait, what's the... Digit logs should be put in their original order. Letter logs are ordered. Oh! Oh, that's interesting. Huh. Oh, I was thinking the digit logs come after the letter logs, after you've sorted it. No, the digit logs just literally don't move their positions. Oh, so you've got to interleave your, huh. Oh, that's interesting. There's a couple ways we could do this. I think the simplest way is to just save the indices that are digit log indices, and you know, make the length of the no. Yeah, save the indices that are digit log indices and the indices that are letter log indices, and then just print the next letter log, the next digit log, and just, I don't know, sort of print the next one. So we can say letter log, digit log indices, and we'll say now I need to do enumerate. Interesting question. XIVI. So I think it goes index value. Okay. And then we're going to say, you know, there's like A, B, start of it's 0, 0. Let's say for I in range length of logs. We're going to print, so if I in digit log indices, and then we're going to print the digit log, ret.append digit log of not I, but A, and A plus equals 1, else ret.append letter log of B, and, you know, B plus equals 1. And then that should give you, and then you fuse them together in this way. I think this is relatively simple. Better approach. Output expected. What? What? What is this? Right. I in digit log indices. Yes. Wait, what? I'm utterly confused. maybe the digit log indices are supposed to come first. Maybe I had it right the first time. I just didn't understand. Yeah, I'm really confused now. Right, hold on, hold on a second. This is obviously incorrect, but we'll hold on to it just for the sake of, like, I don't quite know yet what this is supposed to be. What? Also, this is gonna be the last problem we solve. I'm going to bed after this. What is going on? Also, wait a minute, what? Okay, I'm not getting what I'm expecting, and then what they're expecting is not. It's also. Oh, wow. Oh, okay, so these are letter logs. Okay, and these are not letter logs. These are. Okay, got it. Alright, and what do they want? They're saying this input, so we have some letter logs and some digit logs. They're saying the digit logs should just appear. Oh, okay. Yeah. Alright, so wait, what? Why was this not, So I think I did have the right idea the first time around. I think the problem is actually my comparators were a little bit wrong. I suspect. So the letter logs are supposed to come first, and the digit logs come after it. And the digit logs don't change, but the letter logs. So the issue here is you've got this MO and MW. Now, I said MO is coming before MW. They said MW is coming before MO. Why would... Are you supposed to compare it word by word, or are you supposed to join and compare? Because I joined these and compared them. I suppose it's not a join, it's just a flat out or rather you join them with spaces. Oh, okay. Huh. Could try it now, I guess. So excuse me. Excuse me. YOLO. Nice. Got him. Okay. What is... Alright. I mean, you know, that's fine. Hey, I learned something. I learned something interesting about the comparator. That's very... I think I've looked at that in the past, like many years ago. I looked at that comparison function when I was in... when I was still studying in uni. I remember I was like, I didn't fully understand what was going on with this key comparator function. But now I think I have a better handle on it. That's cool, man. I like that. That's really neat. Really neat. Yeah, okay. Alright, so let's get out of here. Order log files. And that'll be our stream for the day. Didn't get a ton of programming in there, but we got some. Yeah, we got some. Could probably get more tomorrow, I think. And yeah, I think that's it for me. So thank you all for hanging out, saying hello. I will talk to you all soon. Got a lot of thinking done today in terms of like what I might want to do for the future. Got some problems done. Let's see tomorrow if we can get through the rest of this page. I don't think we'll get through the whole page, but we can try. It's a lot to go through. Some of these problems you can do very quickly. Some of them not so much. We'll find out. You know, we'll find out. Yeah, we'll do our best. Yeah. And then I'll probably end up going to work tomorrow. Tomorrow's gonna be a long day. Like we're gonna be doing like pretty much 7:30 in the morning till 9 o'clock at night. We're gonna be just programming away, trying to get through as many of these problems as we can in one day. And then if we can get to we'll just try to get through as many of these as we can. We'll just say that. I think in 9 hours we probably can get to more than 9 hours. It's over 12 hours. In 12 hours we should be able to get. It's actually more like 13 hours. In 13 hours we should be able to get through. I think I've done 5 an hour is like typical, is like a pretty fast rate. About 65 problems. So how many are left here? We have 220 out of how many are there that are easy? Well, let's say 220 plus 65 is pretty darn close to 300. So I think it's close to 300. It might be 300. So I think we'll be able to get there. We'll be able to get there tomorrow. We'll do our best. We'll do our best. It's all right. Again, talk to you all soon. Thanks for hanging out, saying hello, and have a good rest of your night. Adios.